we now turn our attention to the half-angle identities. In order to derive these, we're going to start with two of the double-angle identities, specifically the ones for cosine of 2a, which involve only one of the trig functions, sine or cosine of a, and make a substitution and then solve for the appropriate value in that equation. And the half-angle identities will fall right out at us. So for example, we might start with the identity cosine of 2a equals 1 minus 2 sine squared of a. Recall this is one of the double-angle identities for cosine. In this identity, we're going to make the following substitution. We're going to replace a with b over 2. So everywhere we see an a in this equation, we're going to insert a b over 2. And so on the left side here, we have cosine of 2 times b over 2. And on the right side, we have 1 minus 2 sine squared of b over 2. Now on the left side here, of course, this simplifies just to cosine of b, with the 2's canceling out. And so we have cosine of b equals 1 minus 2 sine squared of b over 2. Now notice that b over 2 is half of the angle b. And so what we would like to do is we'd like to solve this equation for the sine of b over 2. All right, so we're going to need to do some rearranging and then eventually taking a square root to get rid of the sine squared. And then we'll be left with just sine of b over 2, and the resulting equation is going to be our half-angle identity. And so in order to do this, we're going to move the sine squared term to the other side. So we'll add that over. It'll become 2 sine squared b over 2 on the left. And we're also going to subtract the cosine b. So the right side will end up being 1 minus cosine of b. We're then going to divide both sides by 2 so that we have a sine squared term alone. So this will be 1 minus cosine b all over 2. And then to get the sine of b over 2 by itself, we take the square root of both sides. And when we take the square root, we need to remember to always take a plus or minus of that square root, because we don't know if we're going to end up with the positive or the negative square root. And so here we obtain our first half-angle identity. Sine of b over 2 is equal to plus or minus the square root of 1 minus cosine b all over 2. The plus or minus will then be determined by the quadrant of the angle b over 2. We already know that sine is positive in the first and second quadrant, and it's negative in the third and fourth quadrant. And so based on that quadrant, we will pick the appropriate sign, either positive or negative, for this particular square root. Now, if we had started instead of with this identity here, involving 1 minus 2 sine squared a on the right-hand side, if we had chosen the other identity, which is 2 cosine squared of a minus 1, which is also equal to cosine of 2a, if we would have followed that through all the way down, same kind of substitution and same algebra, what we would have obtained is the cosine of b over 2 is equal to plus or minus the square root of 1 plus the cosine of b over 2. And so the only difference here is that there is a positive sign inside the square root in the numerator. There is still a plus or minus outside. And so these are the two half-angle identities that we obtain. And again, the plus or minus is determined by the quadrant of the angle b over 2. So the half angle 1/2 b, whatever quadrant that is in, that determines the plus or minus sign in each case. In this example, we want to find the exact values of sine of 15 degrees and the cosine of 15 degrees. We can do this, if we wanted, by using the difference identities for sine and cosine, since 15 degrees is, for example, 45 degrees minus 30 degrees. However, here we want to use the half angle identity to get some practice using that. The key observation to do this is that 15 degrees is half of 30 degrees. And so we're going to use the half angle identities where b is 30 degrees. And so for sine of 15 degrees is sine of 30 degrees divided by 2. And here we're going to choose the positive square root because 15 degrees is in quadrant 1. And so we know in quadrant 1 sine is positive. Since it's a sine, we want 1 minus the cosine of 30 degrees all over 2. The cosine of 30 degrees is the square root of 3 over 2. And then at this point, there's several ways that we could write this particular answer. We could write it, if we divide everything inside the square root by 2, we could write this as the square root of 1/2 minus the square root of 3 over 4, which is one possible way. Or this can be written as, if we multiply the previous step here, if we multiply by 2 over 2, we'll obtain the value of 2 minus the square root of 3 all over 4, which then in turn can be written, if we wanted, as the square root of 2 minus the square root of 3 all over 2. Notice in this last version, the 2 is not inside the square root. We're taking the square root of 4 in the denominator, and it becomes 2 without a square root. So any of these three would be valid forms for the answer for sine of 15 degrees. For cosine of 15 degrees, we apply a very similar path. We're going to have, in this case, it's going to be the square root of 1 plus the cosine of 30 degrees all over 2 for the formula for the cosine of a half angle. And again, cosine of 30 degrees is the square root of 3 over 2. And so we'll obtain sort of the same sort of set of answers, the difference being that we now have a positive sign inside the square root. And so we can leave our answer as the square root of 1/2 plus the square root of 3 over 4. Or if we multiply inside by 2 over 2, we get 2 plus square root of 3 all over 4. Or if we would like a rational denominator, we can write that as square root of 2 plus the square root of 3 all over 2 outside of the square root. And so all three of these are various versions of the cosine of 15 degrees. In this example, we want to find the exact value of the cosine of 9 pi over 8 radians. In order to do this, what we need to observe first is that 9 pi over 8 can be thought of as half of 9 pi over 4. And so we can apply the half angle identity with the angle of b being 9 pi over 4. And since 9 pi over 4 is a multiple of pi over 4, we can figure out its sine and cosine values and therefore can use the half angle identity to find this value of the cosine of 9 pi over 8. Now, one thing worth noting here at the beginning about the angle 9 pi over 8 is that this is an angle in quadrant 3. So this will become important because when we use the half angle identity, we're going to want to choose the negative square root here in order to reflect the fact that in quadrant 3, the cosine is a negative value. So here, we're going to compute the cosine of 9 pi over 8. And this will be the negative square root of 1 plus the cosine of 9 pi over 4 all over 2. Now, this angle 9 pi over 4 is a multiple of pi over 4, but in particular, notice that it's equal to 2 pi plus pi over 4. So it turns out that these angles, 9 pi over 4 and pi over 4, are actually coterminal. And this means that their sines and cosines are equal, since the terminal side of those angles will be the same side. And so we know then that the cosine of 9 pi over 4 will be the same as the cosine of pi over 4. And so we get 1 plus the square root of 2 over 2 all over 2. And then we can simplify this using whichever approach that we'd like. We can do the negative square root of 1/2 plus the square root of 2 over 4. Or we could write this as the negative square root of 2 plus square root of 2 all over 4, where the 4 there is inside the square root. Or we can do negative square root of 2 plus square root 2 with a 2 outside the square root in the denominator. So all three of these versions of this are of the same number and are the exact value for the cosine of 9 pi over 8. In this example, we're given an angle x that's in quadrant 3 whose sine is negative 2/3, and we'd like to find the sine and cosine of the half angle x over 2. So in order to do this, in order to find these two values, we need to know two different things. So we need to know, first off, the cosine of the value of the angle x. This is going to be used in the formula for both sine of x over 2 and cosine of x over 2. So we need to figure out the cosine of our angle x. And we also need to figure out the quadrant of x over 2. And this is going to be useful in order to determine whether our square root is going to be the positive or negative square root. So it turns out that finding the quadrant is relatively easy to do given the information about x. So here we're told that angle x is in quadrant 3. And so another way of writing that x is in quadrant 3 is by writing it as an inequality. That means x lies somewhere bigger than pi, but also less than 3 pi over 2. And so that range there indicates the quadrant, the third quadrant, somewhere between pi radians and 3 pi over 2 radians. And if we want to get an x over 2 in the middle of an inequality like this, what we can do is just divide each part of our inequality by 2. And so we have pi over 2 is less than x over 2, and that's going to be less than or equal to, or less than 3 pi over 4 when we divide 3 pi over 2 by 2. And now what we observe is that we are somewhere here between pi over 2 and 3 pi over 4. If we would sketch this, we see that we know that pi over 2 is the angle that points directly up. That's a 90-degree angle. And 3 pi over 4 points in this direction along the line y equal negative x. So this would be 3 pi over 4. And so our angle, our terminal side of our angle, lives somewhere here in this range, which is part of quadrant 2. And so what we see here is that x over 2 is going to be in quadrant 2. Okay. So this tells us that the sine of x over 2 is going to be a positive square root. When we apply the formula, we're going to choose the positive square root. But the cosine of x over 2 is going to involve a negative square root, because in quadrant 2, the sine is positive and the cosine is negative. And so now all we need to do is find the cosine of our angle x and apply the half angle identity in each case with the appropriate sign that we just determined. So to find the cosine of x, we can use a right triangle in the third quadrant, which is where angle x is located. And we're told that the sine is 2/3. So we can write this as the opposite side of 2 and adjacent side of 3. I'm sorry, the hypotenuse of 3. We can then use the Pythagorean theorem that a squared plus 2 squared is going to be 3 squared. A squared is then going to equal 5, which is 9 minus 4, and therefore A will be the square root of 5. So our adjacent side here will be the square root of 5. And so the cosine of angle x will be the adjacent side square root 5 over our hypotenuse 3. And then we need to make it negative to account for the fact that angle x is in quadrant 3. Right, so here is our value of the cosine of x, which we will then use in our half angle formulas. So sine of x over 2, we've already determined that this will be a positive value because our angle x over 2 will be in quadrant 2, so we'll do a positive square root here. And the formula for sine of x over 2 is 1 minus the cosine of x, and the cosine of x is negative square root 5 over 3. And then all of that over 2. So we have the square root of 1 plus square root of 5 over 3, all over 2. And if we wanted, we can write that as the square root of 1/2 plus the square root of 5 over 6. And there are other ways that we could potentially write this, but this one is good enough for our current purposes. So we'll just leave it in this particular form. For the cosine of x over 2, we're going to apply a very similar strategy. However, it is important here that we note that we do need to take the negative square root in this case because in quadrant 2 cosine is negative. And so here we're going to do 1 plus negative square root 5 over 3 all over 2. And so we end up with the negative square root of 1/2 minus the square root of 5 over 6. And so, again, we could rewrite this by writing a common denominator inside the square root if we wanted to, but this is a perfectly fine version of this number. And so here are the values that we were looking for. The sine of x over 2 will be the square root of 1/2 plus square root of 5 over 6. And the cosine of x over 2 will be negative square root of 1/2 minus square root 5 over 6.